Today we're going to be graphing linear inequalities. Yesterday we were graphing linear inequalities that were in slope-intercept form. So today we're going to be dealing with some that are not in slope-intercept form. But we're going to find this is pretty much the same as graphing an equation that's not in slope-intercept form. The first thing that we're going to want to do is put it in slope-intercept form. Other than that, we just need to make sure that we remember the differences between graphing equations and graphing inequalities. So let's go ahead and knock those out as our 2 key points for today. They were the same 2 key points as yesterday. What's the difference and what are the things that we have to think about and or do with inequalities that we don't have to do with equations? Jordan, give me one. So this is kind of a third key point. When solving the inequality, you must flip when multiplying or dividing by a negative. When solving an inequality, you must flip when multiplying or dividing by a negative. Okay. So that's a key point about solving inequalities for y, which we have done before. So that's something that we had to remember then. I want to focus our other 2 key points on the differences in the graphing. What are the 2 differences in the graphing? The 2 things that we have to make sure that we know when we're graphing. Frida, give me one. Dashed or solid? What gives me a dashed line?
Polka dot line.
What gives me a dashed line? Desiree? That would not give me a dashed line. Michael?
It's like it's the same, but there's an inequality symbol.
Edwin, add some clarity to that, please. Greater than or less than symbols. What gives me solid lines? Jordan. Less than or equal to and greater than or equal to. Okay, what's the other thing that we have to make sure that we do or pay attention to when graphing inequalities? Michaela.
You said pick what you call it, and
We'll call it a point. And can that point be on the line?
Random point. No. Yeah. No. No, it ain't. No.
Okay, pick a point, not on the line.
And check it.
To determine which side's the shade. Now that we have our key points for today, we can move forward. We already know how to do this. Most of us probably could have done this on our own without any review or any work by me. So we will go ahead and start this quickly and efficiently. So this first problem, it says that 4x plus negative 3y is less than 6. What's the first thing that we need to do if we want to get ready to graph this inequality? Michaela. Yes.
Add a negative 4 to both sides.
So, all right, so negative 4 plus 4x plus negative 3y is less than... Oh, you didn't say x.
Well, but you know what I mean.
I didn't, I guess. because I didn't put it. Oop. I divided by -3. What else should I be doing? Francel. Flip the inequality symbol. Now, let me ask you a question. If I forget to flip that, is that actually going to change how I end up graphing this?
Nope. Yeah. Not at all.
Not using the steps that we use, okay? If we use different steps, that might lead us to a different answer. But the fact that we go back and we plug all the way into the original inequality, that's actually not going to affect us in our graph. However, if the question only asks us for the inequality itself, then we will have an error. Okay. So here we want to go ahead and graph. So I need to determine my slope and intercept. So we want to find our slope and intercept. And go ahead and graph those points. Now, as I graph those points and I get ready to draw this line, what do I need to be thinking about as I'm getting ready to draw the line? Since this is an inequality, what should be in my brain about when I'm getting ready to draw this line?
It's not a solid line.
Quintana? Yeah, dashed or solid. So I'm coming back up here and I'm looking at my inequality symbol. I see my inequality symbol is not or equal to, so this should definitely be a dashed line. So at this point, I've said, hey, this is my borderline. These points are not part of the solution. So now I need to go ahead and do my work to figure out what is part of the solution. So what do we do to figure out which side is part of our solution, Hassine?
Pick a random line. Pick a random dot that's not on the line.
Pick a point that's not on the line, and 0, 0 is usually the easiest to work with. And with standard form, it's super easy to work with because we end up with multiplying both terms by 0. And so we really just get 0 plus 0 is less than 6. 0 is less than 6. That's correct, which means we want to go ahead and shade the side that it's on. So as I said earlier, if we make a mistake and we forget to flip the inequality symbol, the way that we graph it, that's going to be okay for our graph. It's not going to be okay for our inequality, but it will be okay for our graph because we always check by going all the way back to the original. And that's part of the reason why we do that. All right, looking at the next one. Monica, first thing we need to do. Distribute the 6. We'll do a leaf chain switch before that. Y plus -4 is greater than 6x plus -12. Patrick, next. Y plus -4 plus 4 is greater than 6x plus -12 plus 4. Y is greater than 6x plus -8. Slope is 6/1. Y-intercept 0, -8. We'll come through and we'll graph. Rise of 6, run of 1. rise of 6, run of 1. Now, before I draw my line, Francisco, I need to think about something. I need to think about whether this is dashed or solid. Which is it?
It's dashed.
Layla, help him out, please. And why? And why? Yeah, it's greater than, not greater than, or equal to. So this is not going to be part of the solution. Now we need to determine which side to shade in. I'm going to plug in good old trusty 0, 0 because it's not on my line. Zero plus negative 4 is greater than 6 times 0 plus negative 2. Negative 4 is greater than 6 times negative 2. Negative 4 is greater than negative 12.
Correct.
Negative 4 is greater than negative 12. Yeah, I'd much rather only owe $4 than $12, so this is correct. So that means, again, we're shading the side that the 0, 0 is on, since that statement was true. And we'll do one last problem. All right, this one is an other form. What's the first thing that I need to do here, Mauricio? Leave chain, switch, and distribute. It's going to give me 3y plus negative 6 is less than or equal to 6x plus negative 24. Next step, Noemi. Add a positive 6 to both sides. Next step, Michael. Divide each side by 3. Again, always remembering to divide the entire part by, or the entire side by 3. Gives me y is less than or equal to 2x plus negative 6. Gives me a slope of 2 over 1 and a y-intercept of 0, negative 6. So we'll go ahead and we'll graph these points, starting with our y-intercept. 1, 2, 3, 4, 5, 0, negative 6. A slope of 2 over 1, so rise of 2, run of 1, rise of 2, run of 1. And I need to be thinking about whether it's dashed or solid. Desiree, dashed or solid? Why solid? Because it's what? This has got the or equal to portion to it. Now we need to determine which side of this line that we are shading on, so I'm going to plug in a value, a point that is not on the line. I'm going back to good old trusty 0, 0. And that's going to be 3y, or 3 times 0, plus negative 6, is less than or equal to 6 times 0 plus negative 4. 0 plus negative 6 is less than or equal to 6 times negative 4. Negative 6 is less than or equal to negative 24. Negative 6. No, I'd much rather owe somebody negative 6, $6 rather than 24. So this is not a true statement. Since that's not a true statement, we do not want to shade in the side of the 0, 0. We want to shade in the other side. So that's, this case, the right-hand side. We're good to go. Any questions about our work for today?